Thank you. Thank you. It's exciting to be here in Krakow. Looking forward to meeting all of you later. Yeah, as it was announced, my name is Marko Letic. And I'm here to talk to you a little bit about data visualization and how you can include some of these things in your project. So basically, the goal of this talk is to give you a couple of insights and ideas and to show you some cool tools you can use so people will remember your work. So first of all, yeah, I would just like to remind you to use slido.com for questions. Code is Sphere IT. There should already be a couple of polls there, so feel free to vote and play around. We'll discuss these things later. So a couple of things about me. Yeah. Well, I'm a developer advocate and front-end lead at Ava. It's a Berlin-based company, and there we do interesting things with data visualization. We monitor safety risks all across the globe, and accordingly, we notify our clients per their needs. So yeah, I do a lot of data viz, so that's me. I'm also a tech speaker at Mozilla, where I usually speak a lot about open web and interesting things you can do with data viz, with WebXR, and stuff like that. And yeah, I also have a lot of interesting Firefox stickers. If you're into that, find me later. I'm also the organizer of Armada.js. That's the biggest JavaScript conference in Serbia. It's happening in Novi Sad. So if you ever want to visit Serbia, but you don't have actually like a good reason, I think this is a pretty good reason. So come visit. It's interesting. We will do this next year at 1st and 2nd of October. Yeah, I'm also working on my PhD in data viz. You know, there's the working part. So this is how I'm working on my PhD. Yeah, of course, JavaScript enthusiasts. And yeah, I love CSS. Oh my God. And you can follow me on Twitter on Nisam Programmer. I'm not sure how this translates to Polish, but in Serbian it means I'm not a programmer, which is obviously a lie. So that tells you a couple of things about me. Yeah. So let's go. So what is data visualization? In a nutshell, data visualization is the visual representation of information. So obviously, this doesn't work, right? So you kind of get the idea of what we want to do. I mean, already it's just text, but it still needs to be represented properly. It is the definition. So why do we do this? Well, we want to help people to understand information quickly. So right now we're living in a time where there's so many different data inputs. We're handling so many different things at the moment, and we really want that our data gets to our user and in a meaningful way. So we want to have some way of having relationships and patterns in our data to be easily visible, and that our clients, our users, our friends can actually see what this data actually represents. And yeah, see the significance of this data. But the most important thing is to communicate effectively by telling data-driven stories. Well, not everything has to be a story, but if it's a story, I think it's far easier to learn and to memorize and to like kind of adopt. But even if you're not a real storyteller with data, you can actually do a lot of interesting things. So we're going to see a couple of them. And yeah. Make the world a better place. Why not? We're programmers, we're engineers. That should be our end goal, I really hope. So, did you know that the beginnings of data visualization are strongly tied to solving some of the biggest problems humanity has ever faced? If you didn't, we go into history, but not a lot. So, what we see here is probably one of the oldest examples of data visualization in the world. This was made by Michael Florent van Langren. He was a Dutch mathematician and astronomer. And this graph, I would say, represents an estimate of the distance in longitude between Toledo and Rome. So what is the problem here? So back in the day, and I have to say, like, I'm a huge scientific history buff, so like, I really love this thing. It was extremely difficult back in the 15th, 16th, 17th century to figure out the longitude when you were in maritime, so when you're at sea and you couldn't see the land. And that was one of the biggest problems that actually prevented humanity from exploring the world. You can actually see that his estimation is where there's Roma written there. And you can see that tiny arrow, that's where it actually is. So he also was mistaken, but, you know, kudos for trying. And yeah, that's how all these things started. There's actually an excellent book called Longitude, if you're interested to find out more. This problem was solved 100 years later by a man who was originally like a carpenter, and it took him 31 years to solve this problem. But yeah, eventually he was able to do this, and now you have that chronometers that solve this problem, and that, of course, expanded the exploration of humanity, not by just maritime exploration, but also aircrafts and everything else. Now we have GPS, it's a whole other thing. Another problem. So what we're seeing here is the cholera outbreak in Soho, London, 1854. So if you're a buff on Game of Thrones, remember this guy, Jon Snow. So Jon Snow was an English physician. So in the 19th century, there was a huge problem with cholera. A lot of people were dying. Like, I think 660 people died because of cholera, and they couldn't figure out what was the cause of this problem. So what Jon Snow did, he actually visualized where the outbreaks were happening, or like where were the locations of the people who got sick. And he mapped this. I, of course, modified this a little bit with these red and blue things. So the red dots are the outbreaks where the people who were sick were located, and the blue faucets represent the water pumps in Soho. So he visualized these two things, and then he figured out, wait, so like most of the people that were infected were like, they all revolve around one water pump. So is it possible that this water pump is actually the cause of the problem? So what he did is he actually prevented anyone from drinking water from that water pump, and miraculously everyone got better and the cholera outbreak was prevented. Data visualization. So today, of course, we're facing many different problems throughout the world. So Ebola outbreak, privacy breaches, refugee crisis, housing crisis, hurricanes, climate change, of course, a lot of crises like humanitarian all across the world, not just in Yemen, human rights violations. And I think it's kind of up to us, because we have a lot of this data publicly available. There's a lot of municipal open data portals where you can actually get access to this data. And you can see how this affects other people that are actually there, and all other people that are connected with these problems, and maybe we can do something about it. So yeah, visualization, great way to let your data speak. So what can we do to make it better? Well, I'm a JavaScript developer, mostly, so I'm proposing something radical, JavaScript. Yeah, you know the reasons. Works in the browser, very versatile, awesome community, that's you guys. And we can do many different and interesting things with JavaScript, and I'm pretty sure you already tried some of these things. There are so many frameworks right now available to do different types of data visualizations. And of course, like, you should definitely try, not all of them, but some that work for you. But of course, you can always start blank, do everything on your own. There are some tools, of course, that can help you and speed up your project. And we're going to talk a little bit today about some of those tools. So yeah, I'm going to demonstrate a couple of open source projects and solutions, but of course, I'm not saying things that that I'm going to describe here are the best. No, those are just some of the things that I use, and I find them very useful. And of course, you have your opinion, and we can discuss about these things. So basically, I'm just saying you should maybe try it out. But if you don't see there's anything here that can solve your problems, I'm really willing to hear you out. And I would love to see new libraries and frameworks. So, of course, D3.js. We all know about this. So it's an interactive data visualization platform, library that has a lot of tools to like kind of give this database documents like significant meaning and representation. So its name D3 is short from data-driven documents. It was developed by Mike Bostock. He was a New York Times graphics editor. I'm not sure if he actually still is. But one interesting fact here, he was nominated for an Emmy because of D3. You didn't know that, right? So like if you want to win an Emmy, JavaScript. So yeah, D3 helps us a lot. But, and although it's an amazing tool and I really use it like almost weekly, there are some problems D3 cannot solve that easy. And usually these problems are revolved around geospatial information. As we're living today, like in an age where everything is connected, when like you're connected with your friends from all over the world, when we see what's happening in every part of the world, every single information has a geographic representation. So if you want to display something on a map, D3 can help, but it might not be the most optimal solution there. So we go to Deckgl. So it gives us kind of a layered approach to data visualization. It was built by Uber open source, and it's still heavily supported. So everything you do in Deckgl, it's like for you to extend and modify however you want. It has a large-scale WebGL-powered data visualization, and it has a layered approach to data viz. So what this means is actually you can build several different layers on top or like intertwined, and you can include them in your projects. And what it does, it has a high-precision computation in the GPU, so it emulates 64-bit floating point in the GPU, so it gives you an additional performance. And yeah, it has a lot of different and interesting integrations. I listed here React and Mapbox GL, but we'll talk about this a little bit later. So yeah, most of the things you can basically see on the website itself, like regarding documentation. So you can see examples, you can see showcases, blog posts, and basically links to any GitHub repositories that are linked with Deckgl. If you're like interested into this, I really advise you reading their blogs because they have very, very interesting topics there and like go into many different spheres of not just development or like just products and general purpose usage. So yeah, so I've set up already a couple of polls with Slido, but I can assume that some of you has already used D3. So what we see here is a couple of different ways of how we can basically represent our data on the map. So in the top left corner, we see some icons that are basically clusters. On the top right, we see hashtags that represent locations, which are also clusters. On the bottom left, we see some interesting visualization with some kind of a scatter plot. And on the bottom right, we see arcs. So what you can see here is basically a lot of points. So top left corner, 45K, top left corner, 45K, top right corner, 67K, 858K, which is like crazy if you think what you could do like 5 years ago. And yeah, so what Deckgl offers you is basically an interesting way how you can instance these layers and how you can use them in your projects. So with D3.js, you basically, if you wanted to, let's go with the top left. So if you wanted to display a marker or a circle or something, you had to feed it with data. So you had to have one-on-one mapping with the objects and with the circles that actually represent the graphical representation of this. So what you wanted to do is like kind of quite slightly tweak the circle. So it has a different radius, or it has a different property, or different color, or something else written on top of it. And that can create a lot of problems if you're handling tens or hundreds of thousands of data points. So WebGL has a nice feature called instancing, where you can actually very cheaply create visual object instances. You can clone them, and you can tweak them. So as I said, like we have example here with 4 layers, but creating a layer with Deckgl, it's pretty straightforward. So what you have to do is you actually have to use one of the already existing layers that are there, but what Deckgl does, it also gives you an option to extend the layers. So you can write your own shaders for the layer, you can do whatever you want with them, like you can have custom drawing, custom picking mechanism, and many different things. You can also have composite layers. So if we're talking about geospatial data, usually there's some GeoJSONs revolving there. So if you want to parse them, they usually have some multiple geometry types. So that can be polygons, that can be some lines, whatever, like paths. And what this offers us is to basically parse multiple types and actually give the option to Deckgl to decide on which layer, like we will tell him, of course, which types of data will be used with the different layer. And then we can maybe combine all of these things together. You know, don't do that. That would be just crazy. But yeah, we can create a lot of adapter layers. So what we see here is how it does some high precision computation. Don't mind the lag. The lag is because I screen recorded while I was working on it. It works a lot smoother. You will see it later. What we see here is every person in New York City. So each dot represents 10 people. So 2015 census data. Open data, and you can actually see how many instances Deckgl is drawing on the map. So keep in mind, it does work smoothly. And what it offers us is basically to change the radius of the data, and it looks pretty interesting. What is cool here is it has a map below it. So here we're using Mapbox as a tile provider. Deckgl has a really good integration with Mapbox, so it can match the camera movement. So you can tilt the map, you can pan, you can zoom, and do many different things, and that always reflects the Deckgl visualization that you have. So this is a different example, but still we're talking about the same thing. So we see here around 1 million vertices displayed. So this represents taxi trips taken from 9 to 9:30 p.m. So this is 10,000 trips in New York for 30 minutes. And you can see the visualization of all of these things. So everything you see here works in the browser. What is cool about Mapbox and why I personally love to use it is because you can extend it in many different ways. There's Mapbox GL library that lets you play around with many different layers and many different types of visualization. So you can see here the buildings that are rendered in 3D. So how does this actually work? Mapbox bases its data on OpenStreetMap data. So if the data in the OpenStreetMap format has a height and a proper dimension, you'll get this pretty nice looking buildings. But if you're doing this in a city where OpenStreetMap hasn't mapped the height of the buildings or their, I would say, like exact dimensions, then it will actually just extrude the height of the object for some fixed height. So it won't actually be, I would say, like real representation. But this also goes into the sphere of kind of open source and community, because everyone can actually modify the OpenStreetMap data, and you can contribute with your city. Like a lot of universities all across the world, they're, I would say, like architecture departments, students, interns do the mapping of the cities, and this is how actually New York was mapped. So you can see that we have like high precision rendering, and it's a totally dynamic range data. So as I said, like it emulates a 64 floating point on the GPU, and that's how we are able to get this performance. So what it also does is you still see like a map under it, but it's like pretty darkened. So one of the cool things you can do in Mapbox is you can actually select the look of the tile layers that you're gonna display there. But it gives us real-time data aggregation and filtering. So here we're using 140K accidents. So this is road safety from the UK. But you can see that in real time, I'm changing the coverage, the radius, the percentile, and it actually in real time changes the visualization. Once again, laggy is because of the screen recording. So yeah, it gives us on-the-fly interaction, which is amazing. So one thing that I should probably mention is when we're talking about amounts of data, so like what is the limit, what is the peak? If you're going with a couple of hundreds of points that you want to visualize, that will probably be okay, and that will be okay with Deckgl. But if we're talking about millions or maybe billions, then you have to be a little bit creative. So I can tell you a little bit about what we do at Ava. Is we actually handle billions of points that have their geospatial position, they have some categories, they are time framed, and in some cases it's very important for our clients to see this data. So you can imagine that displaying billions of data points on one map can't really work like out of the box. So if you want to visualize something like that, you'll probably have to have some in-memory database. So when I say in-memory database, I mean CPU or GPU in-memory database, which is able to filter this data pretty quickly. And then you have to build your own rendering engine. So to be able to build your own rendering engine, that's not that hard. You actually just need to create something that will overlay a PNG, like that will generate a PNG that you can overlay on top of the map. And then on top of that, you can use maybe something like Deckgl to visualize the most important points of your project. But okay, so not everyone are like doing geospatial things, right? So you can also do something that is not map related. So here we have some, I would say like a building apartment, 2 stories, that has almost 1 million points. So this is generated with LiDAR. So LiDAR stands for light detection and ranging. So it's basically a surveying technique that scans the surface using a laser light and returns like a densely populated 3D point cloud. So LiDAR lets you answer some of the questions that were previously like impractical or impossible to answer. So you can actually calculate some of the things where it's LiDAR is heavily used. Like you can have like tree coverage around your city. So you can actually figure out how many trees are in the city if you just go with a car that has a LiDAR. That can give you like pretty decent results. Like FEMA uses LiDAR to when they plan for the upcoming hurricane seasons, because they're calculating what is the amount of trees, and then they know what will be the wind speeds in different areas of the city. So LiDAR can be, I think, pretty interesting thing. But of course, if you're not doing geospatial things, like Deckgl can give you really nice data visualization. You don't have to, of course, use LiDAR. Not everyone has this LiDAR, but you can import different 3D models. You can play around with them, and Deckgl will give you the versatility of this to work smoothly in the browser. So now you're asking, how does it work? So we're all developers. Of course, we want to know how these things function in the background and how we can use them and how can we reuse them and extend them and modify them. So I will assume that most of you here has used already React, Angular, or Vue.js. So you're already probably working on some of the projects at your company, or maybe some open source or like fun and games projects where you use these frameworks, and you have your UI. So what you want to do, if you want to use something like geospatial projects, like you want to use Deckgl for geospatial project, you'll definitely need to have a map. So to have a map, of course, there's a wide selection. Well, not so wide selection. There are several options. I listed Mapbox GL because it gives me the biggest versatility, I think. But if you want to go with Google Maps, that's also cool. But what is important is that you need to have a wrapper around the mapping library so it can integrate easily with your already existing project, or like the framework that you're using in your existing project. So the map itself has to be wrapped or around like with some React, Angular, Vue.js plugin. And yeah, so once you add this, you can do some overlays. You can do some different layers. So it's important to say that frameworks like Mapbox GL and Google's, they already have an option to draw layers on top of the map. But we're not talking about like hundreds of thousands of points in those layers. So if you want to do something like that, out-of-the-box solution does not work. And that's where Deckgl comes into play. So you already saw how we can use Deckgl to visualize this, and it has several options and many different layers on top of it. But what it has inside is something called LumaGL. So what LumaGL does is basically a companion to WebGL framework for Deckgl. So it's a ES6 code base that's using classes to wrap main WebGL1 and WebGL2 entities. So it is WebGL2 ready. So it has textures, transform feedback, and stuff like that. Also, maybe reading something like how LumaGL works and how the code looks might be interesting for you if you want to start into WebGL and understand what it does, because it wraps some of the main features there. But let's say you're using a React app, and in the React app there's some data that you would like to visualize. So I have to say, I'm not a React developer. I do a lot of Angular, I do a lot of DataViz, but not so much React. So if you have some questions on React, I will look bad. But let's say you have your React components, and the component itself has some data you want to visualize. So you'll just get this data passed to Deckgl. And if you want to visualize your data with a map, you will need, as I said, like a wrapper around your map library. So because I gave an example with React, we will use something called React MapGL, which is a wrapper around Mapbox that has an excellent integration with Deckgl. And it works really, really nice. So, but of course, there's always the question, I'm not using React. I'm not either. So if you want to use something like Angular and Vue, of course, there are solutions, and the solutions work. But the team at Uber Open Source committed a lot of hours in making Deckgl, LumaGL, and many different open source projects that are in the same ecosystem. And they didn't actually have a lot of time to do, I would say, nice wrappers around the mapping libraries that work with Deckgl. They worked on React MapGL, but nothing, I would say, similar exists for Angular and Vue that's relatively easy to use. So if you want to do something in Angular and Vue, yes, of course, you can do it. But it might not be that smooth and easy as React. So when you go into the green square and we go into Deckgl, we see that he uses something called Layer Manager. And what Layer Manager does is he manages multiple layers, like GeoJSON layers. And so if you're parsing the GeoJSON data, he can offload a lot of the computations to a point layer, polygon layer, path layer, etc. So everything here happens behind the scenes. You don't really have to know a lot about it, but if you want, source code is publicly available, and it might be interesting for you to read. So that's kind of like the general overview of how these things work. But what's very interesting is how Deckgl integrates with the map itself. So what we're seeing here is we see several layers. So we see Mapbox's label layer. So that's where the street maps, like the street names are, maybe even some tiles. And we see the Mapbox's building layer. That's the layer I previously explained. So it's extruded height of buildings based on OpenStreetMap data. And let's say you want to do 2 layers in Deckgl. So one would be a scatterplot layer. The other will be an arc layer. And you generate and you merge these things into a Deckgl canvas. And you have a Mapbox GL canvas where the street names are and the buildings in 3D, everything is there. And now you merge all of these things together, and you get a result that is displayed here. So what you can see already is that the integration itself might not be the best option. So like it has a DOM composition. So what the guys at Mapbox did, because they saw how where the data is going, they actually merged these things. So in one of their releases, they enabled third-party layers to draw into the same WebGL context as the Mapbox map. So you basically can hook up to their already existing system, and you can draw the layers in the basically same passage as you as the Mapbox does with their labels and buildings and whatever layers that you want to display here. So this opens many different possibilities for more tightly integrated geospatial visualizations. So for example, Deckgl GeoJSON layer can be included very easily here. Yeah, so we see here how this integration works, and it's pretty smooth. So you can see that the arc layers are actually intertwining with the buildings. So when the building starts, the arc layer ends. And this is what this integration does. So it kind of cohabits the space. So if you want to use it with React, you just have to import a couple of libraries. Not a big deal, right? So React, Deckgl React, layers, React Map.gl. So you want to set some initial values. Mapbox has its access token, that's for the API. You want to visualize some initial view state, longitude, latitude, zoom, pitch, bearing. You can do without this, but it makes sense to go somewhere, right? And data to be used by the line layer. Let's say we want to display a line layer. And then we just need to pass this data to our Deckgl React component. So we create our line layer, and we create our Deckgl component where we pass our initial view state, and we pass our layers, and we have a static map that's wrapped, that's inside the Deckgl component. So all of these things work together. Pretty basic, pretty simple. So yeah, it seems that I've talked too much, so maybe if you want, you can check out these examples. So like you can scan the QR code, and it will take you to some of the apps that are already using this. It should work with your phones. I cannot promise it will work with all the phones, but it definitely will work with some. Most modern phones in modern browsers, this should be working. So this is Flight Mapper IO. Basically, you can track your flights throughout the world. It uses Deckgl with React. This is with Angular. So as you see, it's of course possible to be done, and it works on your phones like it works. I tested in Firefox, I tested in Chrome, I tested in Safari. So you can play around with these things. They're usually very interesting and interactive. So a couple of real-life examples. We have Kepler-GL. It's a very powerful open source geospatial tool. We have AVS, one of the most interesting things, I think, right now. So this is an autonomous visualization system built by Uber that actually gives us 3D visualization for building applications for autonomous vehicles, robotic data. So all these cars have a lidar inside. They map the street. But everything you see here works in the browser. That's WebGL completely. So everything. So you can see actually the top right is the camera, and what the car sees you actually get in WebGL. So it consumes data in XViz protocol, so enables log viewing, simulation, and debugging in a web app. So there's a framework called Streetscape GL that uses Deckgl. That's kind of on top. Streetscape is on top of Deckgl that has many different things that you can track. So like it uses the XViz protocol, so you can see acceleration, metrics, many different things that you can use. So you can actually import your data in these tools, and you can visualize them. So yeah, still WebGL, Deckgl, Streetscape GL, a lot of GLs. So there's also many different projects. This is for SiteAI. Their goal is to build like kind of largest driving scenario database for training and validating automating driving systems. They also use Deckgl, but they've extended it, so you can see that is their project. And yeah, if you want to do something interesting, this is still Deckgl. But I changed the font size. So now you can see the text. So it uses the text layer API to convert pixels into characters on the fly, but you need to have WebGL2 compatible browser. So a couple of references that I have to mention. So WebGL's website, of course. WebGL is the working group from Uber. Nico Belmonte, he was the team lead at DataViz in Uber. He now switched to Mapbox. A lot of interesting lectures and blog posts by him. Definitely read them. Leisurely from this year's Open Summit in Sofia. Xiaoyi Chen, excellent blog on DataViz. I really love this. And just generally on DataViz, micro-friendly, Milestones project. So you remember my history with Van Langren and Jon Snow. There are so many different interesting examples in his Milestones project. Like he dedicated his entire life to DataViz. Alberto Cairo, The Truthful Art, Hans Rosling, Factfulness, Mapbox's blog. And yeah, so you see what you can do with DataViz. So now it's your time to save the world, right? And follow me on Twitter to find out more. And yeah, so next time you want to code, think about how your projects can impact the world and use the code for good, not evil. So yeah, thank you.
Thank you very much.